Oh, okay.
It's just the way the discussion flowed. I want to make sure that we talked about everything. I'm going to come back to that website just because it's kind of a cool one. The one piece that I wanted to show you. Oh, it's coming up on the next slide. Okay. The next slide then is just kind of, to me, it's one of those kind of neat effects that plays, or that comes about because of the pigments in the retina of the eye that absorb specific wavelengths of light, and then they re-emit that, or they send the signal through the optic nerve to your brain. And if a cell gets tired, it ends up that that cell will send a weaker signal to your brain than the other cells around, and as a result, colors can end up changing. And this next thing is going to be kind of a cool effect that illustrates that. I'm going to hit the slide. It's going to bring up a picture that you'll recognize of the American flag, but the American flag is a little bit bizarre. And what I would like for you to do, I'm going to have you stand up somewhere, get to a position where you can see it nice and easily, and I'm going to have you focus right there on that star. Okay? So what I'm trying to do here by having you focus on that star is keep your eyes fixed exactly on that one spot. Now, as I mentioned the other day, your eyes normally tend to bounce around and move so that light shines on different parts of your retina all the time, and so your brain is continuously getting all this data. But if you keep focusing right there, then you'll keep the same color of light focusing on the same retinal cells over and over and over. And kind of for a timing mechanism, I'm going to have you just say the Pledge of Allegiance, and we're going to say it 3 times so that you look at it long enough for the chemical reaction that needs to happen. So I'm going to sit down here. You guys get wherever you need to so you can see that nice and clearly. All right, everybody ready? All right. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, with liberty and justice for all. Keep going.
Are you in Spanish 4?
Okay, keep staring.
It was like the real colors.
Yeah, you can't, I saw it was like the real color.
Yeah. So why is it that the after image that you end up seeing is the real color? Yeah, you keep staring at it. You say the image should be there for a couple minutes. I was purposely not looking at it because I didn't want to keep seeing it all over the place where I was moving here. But why did you guys see a true color after image?
Those
What
are
is
the
the complementary
complements.
color of cyan?
Red.
On the opposite side of the picture from cyan is red. So where the cyan light from the stripes and the flag that were cyan, where those were hitting, those cells were getting tired. So when we just got rid of the picture and all you were seeing was the white screen, the cells that had been getting that signal from the cyan were now sending a weaker signal. The other cells were sending a stronger signal, and so you were seeing the complement. And the complement of cyan is red. And then the yellow, what's the complement of yellow?
Blue.
The blue. So where the yellow light was falling continuously on the retina, the yellow light, those cells were getting tired and sending out a weaker signal, so that when we went to the pure white screen, then the cells that sent the yellow were now sending a weaker signal, the others are sending a stronger signal, and you see the complement, you see the blue. And the same thing for the rest of it. So it's a complementary flag, it's the opposite colors on everything, so that when it switches, you end up, the after image that you see is the correct image.
So, like,
Oh, let me get this question, I'll come there.
so, explain how a video works. Like, I've seen a YouTube video one time where it's like black and white lines and a bunch of them are moving all over the place in a certain pattern, and then you look away and your vision's all waving. How does that?
Well, let me go to that website that I said I want to come back to. Before I do that, though, did you have a question about this one too?
Yeah, like, so, I don't know if this is the same idea at all or not, but say you have fireworks and you put a flag up in the sky like that, we're looking at, would the after image be the other one, or do you have to like absorb all that light for a while?
You've got to do it for a while. It's got to be long enough that those cells that absorb that are sending a weaker signal than the neighboring cells. So you'll tend to see an after image anyway. You know, anytime you see a bright light, you'll see an after image that kind of then ultimately fades out. But to make it that true color after image, you've got to have the right color, the complementary color, hit those same cells for a significant period of time, and then all of a sudden that real image has got to be gone, and the after image then will be in real color.
Okay.
Are you like messing up our vision?
Am I messing up your vision?
Yeah, because you said our eyes don't want to look at stuff for that long or focus on
Oh, no. It hardly ever messes anybody up permanently.
it. Okay.
No, it's just, all I'm doing is making sure that, is taking advantage of how your body works to point out particular concepts.
Okay.
But no, it doesn't do, I've never had anybody complain of permanent damage from any of these demonstrations. Yes?
So the
Okay.
after image concept is like why
Let me ask this after
chemistry
chemistry
sun
fire.
you plug that into
I never had chemistry.
Yeah, in that case, it's because those cells where the retina,
No.
where the light hits in the retina, got a whole bunch of energy all at once, and they got really stimulated, and so they're still sending that image. Whereas this one is those cells where the light was hitting were getting tired, and they were sending a little bit weaker signal than the others. Ashley, your question though reminded me of, this is one of the reasons why, you know, if somebody is ever welding, or you're welding, you always say, you know, cover your eyes, don't look at welding. Because it produces a lot of ultraviolet light, which all this stuff can happen with that too, and you don't realize that you're seeing the ultraviolet light because it's invisible to our eyes, and that stuff could do damage with it. So never do any of this stuff around ultraviolet light.
Not
All right.
often welding stuff.
This site then is kind of a cool one.
I'm just all the time just welding. It's like my hobby. I'm glad that happened. I'm glad you started singing as soon as you said that. It's definitely a nice addition.
Okay, Andrew was talking about various optical illusions then. And so there are several illusions that occur because of these things that we were talking about. One of them is the persistence of vision, which is the idea that when you see something, those signals, the cells on your retina will continue to send a signal to the brain for a little while, as long as that chemical is breaking down, whether the thing is still there or not. Part of that is how your brain sees things, even though there's stuff in your blind spot. Your brain kind of fills in that spot due to the persistence of vision because your eye on its own normally moves around. And so it leads into some kind of interesting illusions then. And this is a site that I found that just had several of them that I thought was really pretty cool. And let me see if we could get some of them going.
Those eyes are reading me out.
In this one, the yellow rectangle and the blue rectangle are both moving at a continuous speed across. And in just a second, there's a thing here where I can click it, and it will take the bars out of the way, and you can see what's going on. And let's see, where are my bars? Oh, I thought I could go to 0.
Why does it do that?
So why does it do what it's doing?
I don't know.
When the yellow one is moving across the black, what happens? You can see that well because there's contrast, but when the yellow rectangle is moving across the white, you can't see the boundary very well. And so as a result, it makes it look like each one of them is stair-stepping, when in fact they're just moving at a continuous rate.
Oh, that makes sense.
I thought that one was going to show me the... Well, I know you used to be able to just get rid of the bars completely. Anyway, let me go back. There's some others. This one's kind of cool. And this one, it works well on the computer screen. I'm not sure how well it will work for there. You guys just need to focus on the red dot. And the yellow ones will just periodically just drop out of your vision. They'll just disappear.
Yeah.
But if you focus on the yellow dots, you see that they never actually do disappear. They stay there all the time.
That's so weird.
Why is it?
And that was going to be my question to you. So why is that? Why do they appear to disappear sometimes?
Because
They call it that peripheral vision.
Yeah, as your eye is continuously trying to move, your blind spot is now not getting enough, your brain's not getting the right information to fill in for the blind spot. And so it's filling in with what it's getting from the other places, and that yellow spot isn't part of that. And so it makes it appear that the yellow spot is disappearing continuously, or once in a while.
basically what you see is that your eyes are always long. Yeah.
We won't go through all of these, but some of them I remember as being really neat, some